Hi students, today we are discussing about the next chapter, that is oscillation. Now already we know that oscillation is a common and interesting phenomenon in our physics. We are taking some examples of this oscillation, that is the motion of pendulum of a clock. Another example, the vibrations of musical instruments like guitar and violin, that vibrations of that string of guitar or violin, that are the good example of oscillation. The motion of prongs of tuning fork. Another example, the motion of the needle of sieving machine. These are some examples of oscillation. Already we know the oscillatory motion is a periodic motion. In this oscillatory motion, that body or that object repeated after a certain interval of time, and that's why this motion is called as periodic motion. In this motion, the object is mostly moves to and fro or up and down. For example, if we take that example of needle of sieving machine, that needle moves up and down. That is a good example of the oscillation. That means in this motion, that particle or that object moves to and fro or up and down. Now the displacement, velocity and acceleration of this motion can be represented by sine and cosine functions. These functions are known as harmonic functions. Therefore, an oscillatory motion obeying such a function is called harmonic motion. Now, we take the definition of what is periodic motion. Motion which repeats itself after definite interval of time, which is called as periodic motion. What is period or what is periodic time? When that body performing periodic motion goes on repeating the same path again and again. The time taken for one set of movement, that means that motion goes on repeating the same set of movement continuously. Out of that, the time taken for one such a set of movement is called as periodic time or period. Now we are taking some examples of periodic motion. These are the motion of moon around the earth, or another example, motion of electrons around the nucleus. Or there are many examples, that is the motion of all the hands in a clock, that is hour hand, minute hand and second hand also. That are also a good examples of periodic motion. Now what is oscillatory or vibratory motion? When that particle repeating the motion, when that particle repeating its motion to and fro along the same path in equal interval of time, that is called as oscillatory periodic motion or vibrating periodic motion. Every oscillatory motion is a periodic motion. Every oscillatory motion is a periodic motion, but every periodic motion need not be oscillatory. For example, if we take the circular motion is a periodic motion, but it is not oscillatory motion. The simple form of oscillatory motion is a periodic motion. The simplest form of oscillatory periodic motion is the simple harmonic motion, in which particle moves to and fro about its mean position. If the path is straight line, if that motion of that body or that path is a straight line, then motion is called as linear simple harmonic motion. And if the path is an arc of circle, then it is called as angular simple harmonic motion. Then next point is what is the frequency of oscillation? The number of oscillations completed by that body per unit time, which is called as frequency of oscillation. Now the next point is what is linear simple harmonic motion? It is also called as SHM. SHM means simple harmonic motion. Now for that, place a rectangular block. Look here, place a rectangular block of mass m on a smooth frictionless horizontal surface, that is as shown in figure. Attach one end of that string to the rigid wall and other end to the block, as shown in this figure. Now if we take that three figures, that is figure A, figure B and figure C. Figure B, that is a relaxed position, or that is that block which is at mean position. Figure A, that the spring is stretched, and figure C, that spring is compressed. Now in case of figure B, this shows the mean position or equilibrium position, in which that string exerts no force on the block of mass m. If that block is displaced towards right in figure A, if that block is displaced towards right from its mean position, the force exerted by that spring on the block is directed towards left. Look here in that figure A, that force which is directed towards left and displacement x which is in opposite direction. Now in this condition, if x is the displacement and F is the restoring force means what? That force is responsible to regain its original shape, size and dimensions of that spring. That means that the restoring force is responsible to regain its original shape. Then F is equal to minus kx, where F is restoring force, F is equal to minus kx, where k is constant which is depending upon the elastic properties of that spring. It is called as force constant. Negative sign, F is equal to minus kx. Negative sign indicates that force and displacement are oppositely directed. If the block is directed towards, or the block is moved towards the left as shown in figure C, in that case that spring is compressed. And in figure C we can say that the force exerted, in that case also the force exerted by spring on block which is directed towards the right, and therefore we can write F is equal to minus kx. The restoring force exerted by that spring is accelerate the block towards the equilibrium position or mean position. Therefore the acceleration of block is given by A is equal to F upon m. According to the Newton's second law, F is equal to ma. So in that case A means acceleration. Acceleration A is equal to F upon m is equal to F is equal to what? Kx minus kx. Already we know that. So A is equal to minus kx upon m, or in short we can say that A is directly proportional to minus x, where A is acceleration of that block. This shows that acceleration is also proportional to the displacement, and it is directed, direction of that is opposite to that of the displacement. As the block moves towards the mean position, its speed starts increasing due to the acceleration, but its displacement from the mean position goes on decreasing. When that block returns to its mean position, the displacement and hence the force and acceleration are zero. The speed of the block at mean position becomes maximum. Speed of that block becomes maximum at mean position, and hence the kinetic energy attains the maximum value. So what is linear simple harmonic motion? What is linear SHM? Linear SHM is defined as it is the linear periodic motion in which force or acceleration is always directed towards mean position. Figure A and figure C, already we show that. Seen in that figure A and figure C, that means the force and acceleration always directed towards mean position. The displacement towards the mean position, the displacement and hence the force of acceleration, these are zero in that condition. So the linear SHM is defined as the linear periodic motion in which the force or acceleration is directed towards the mean position and its magnitude is proportional to the displacement from the mean position. This is the linear simple harmonic motion. Once again, what is definition of linear SHM? It is defined as the linear periodic motion in which force or acceleration is always directed towards mean position and its magnitude is directly proportional to the displacement from the mean position. This is most important part. Next point is the differential equation that we take in next lecture.